Hi, I'm Kevin Krieger. I'm a research engineer in training with the SuperDARN group at the University of Saskatchewan. We're in the Institute of Space and Atmospheric Studies, and the SuperDARN project is a worldwide collaboration with over 30 countries, and we have over 30 radars that study the ionosphere across the globe. SuperDARN, there's two parts to it. There's the super part, which just stands for super, and there's the DARN part, which stands for Dual Auroral Radar Network. And I'll explain what those four words mean. Dual, meaning we have two radars. Auroral, meaning they pertain to the Aurora Borealis and Aurora Australis. And radar network, meaning we have more than one of these sets of two radars. And SuperDARN, when you get all these sets of two radars together that are studying the ionosphere, we can get the end data product is a global convection map of the plasma that flows in the Earth's ionosphere. And plasma is basically an ionized gas, which is where space weather happens. One example of space weather is the Aurora Borealis. We can see them whenever there's increased solar activity in the north, and there's also auroras in the south, which some people may not know. So there are many radars in the northern hemisphere, and there are many radars on Antarctica, or with fields of view over Antarctica. The Canadians from the University of Saskatchewan, we gather data from 5 Canadian radar sites, and there's one just outside of Saskatoon, there's one in Prince George, and our 3 polar radars, which we call PolarDARN, are in Clyde River, Nunavut, which is on Baffin Island, Rankin Inlet, Nunavut, and Inuvik, the Northwest Territories. And we also collaborate with other research sites in the North Circumpolar region, including Stockseri, Iceland, and Hankasalmi in Finland. Understanding the effects of space weather is important in the northern regions because of the detrimental effects it can have on our infrastructure, such as power lines and communication satellites. One canonical example of space weather having a negative effect on our infrastructure is in Quebec in 1989. There was a massive solar flare, or coronal mass ejection, they're sometimes called, that hit the Earth and caused a blackout in Quebec for, I think, 9 hours or so. And the reason that happened is because space weather can sometimes create large currents in the ground of the Earth, which will flow through our power lines and overload some of our transformers. And some of these transformers can take many hours to fix, if not months to replace. In the future, to mitigate these effects that space weather can have on our infrastructure, we need to get a basic understanding of exactly what is happening in space and what's causing the space weather. So the SuperDARN community is doing this with ground-based radars to try and understand basic processes between the sun and the Earth, how the sun and the Earth are interacting, and what is causing these effects, such as the Aurora Borealis. Several years ago in 2012, a satellite saw a massive coronal mass ejection from the sun, and we were very lucky. We just missed it here on Earth. But if we were to have been in the path of that mass ejection, there are estimates out there that say we could have had trillions of dollars worth of damage to our infrastructure. Continued support for the SuperDARN space research and other space research like it will be very important especially now that there's going to be increasing economic activity, larger populations, and more infrastructure being developed in the north.